Okay, this video is a review for the test. When you take your test, it's going to be part no calculator and part calculator. Problems like these first six are on the no calculator along with the graphing. Everything else is calculator. If you're still not sure, you can look on your test review. I have it labeled in the directions, whether it's calculator or no calculator. Okay, so let's look at number one. Number one wants us to find the square root. Well, the square root of 64 is 8. And in the square root, there's invisible 2 here, so we're looking for groups of 2. So in this 8x's, there are going to be 4 groups of 2, and the y's, there's going to be 5 groups of 2. So we're done. On number 2, we have to simplify the radical. And because it's not a perfect cube, we're going to have to make a factor tree. So I have 2 and 48, 2 and 24, 2 and 12, 2 and 6, and 2 and 3. And we're looking for groups of 3. And each group represents just one number outside of the radical. Anything not grouped up all gets multiplied back underneath. But don't forget, whatever number's on the shelf needs to go right there. You don't want to lose points on your test for that. So underneath, 2 times 2 is 4, times 3 is 12, and I'm putting that 3 back on the shelf. Number 3, anything to the 1/2 power is the square root. So I get the square root of 25, which is 5. Number 4, we are multiplying with the same base. The base is 27. And when you multiply with the same base, you do not change the base. You simply add the exponent. So this is going to be 2/3 plus negative 1/3, which would be 1/3. So when I simplify this, I don't change the base. I have 27 to the 1/3 power. Well, to the 1/2 power over here, number 3 was a square root. So the 1/3 power then would have to be the cube root. And the cube root of 27 is 3. Okay, number 5, when we are subtracting, just like we are in number 5, again, just like 4, we don't change the base. We just subtract the exponents. So 7 minus 5 is going to give us 2. So this is really just 9 squared, which is 81. Number 6, this is power to a power, so we're going to distribute that 1/2 to each one of those. So x 1/2 power is just x to the 1/2. Y, we have 6 times 1/2. Well, half of 6 is 3, so we have y to the 3rd. So we're almost done with our answer, but we can't leave it that way. The y to the 3rd can stay because it doesn't have a fractional exponent, but we need to rewrite the x. But notice I'm going to put the y to the 3rd in front so it doesn't look like it's under the radical. So anything to the 1/2 power is just the square root, and there's our answer. Okay, now we're switching to problems that we can use a calculator for. 4 and 5 are very similar. And so for this video, I'm just going to show 4 because 5 is the exact same process. So on 4, we're looking for groups of 4. On 8, you'd be looking for groups of 5. But if I try this, I'm going to do 648 divided by 2. So that gives me 2 and 324. Well, it's still even. So I'm going to do 2 and 162. Still even. So I do 2 and 81, 9 and 9, and then a bunch of 3s. So when I'm writing my answer, the group represents one number that's outside. And then I'm going to leave a space because I'm going to have some variables. Because it's the 4th root, I'm going to have a 4 on my shelf. Underneath, I have a 2, and a 2. Okay, now let's deal with the variables. We're looking for groups of 4, and I've got 8 x's, so that would be 2 groups of 4 with no left over. With the y's, again, I'm looking for groups of 4. That would be 3 groups of 4. Well, 3 times 4 is 12. That means we would have 3 left over. So when I write my final answer, I have 3x squared y cubed, and then the 4th root of 2 times 2 is 4 times 2 is 8y cubed. But again, don't forget the number on the shelf. And that's the final answer. So like I mentioned, 8 is the exact same idea. It just doesn't, it just looking for groups of 5. All right, let's look at number 9. Number 9, we're multiplying. So when we multiply, because there's no exponents outside the parentheses, we can just start multiplying. 2 times 6 is 12. And then with the x's, they have the same base. and we're going to add the exponents. So to add the exponents, we need common denominators. So they're going to be 6. So 1/2 is 3/6, and 2/3 is 4/6. So we add them together, we get 7/6. Okay, the 12 doesn't have a fractional exponent, so it's good, but the x we need to rewrite. So x goes in the radical, the denominator of 6 goes on the shelf, and 7 is the exponent. But we have to check. We may not be done. We have to see. This means groups of 6. How many groups of 6 are in 7? Well, there's one of them, so I've got to pull the 1 out, and then the 6 is on the shelf, and I still have the 1x left over. Okay, number 10 is still multiplication. The problem is, or not the problem, is that we've got this power in there. So we have to deal with the power to a power first before we can do the multiplication. So this first group over here doesn't have a power to a power. It doesn't change. So I just have 4b to the 3/2. Now I'm going to distribute that 2. And when I do that, I multiply the exponents. Well, this 2 in the problem is an invisible exponent of 1. So 2 times 1 is 2. So this is really 2 squared. And 2 squared is 4. So I'm going to put 4 here. Now with the b's, I'm going to take 1/2 times 2. Well, half of 2 is just 1. So just have b. And with the c's, I've got 1/3 times 2. So when I simplify that and multiply straight across the top, I just get 2/3. Now, number 10 is just like number 9. So first I have to multiply the numbers. 4 times 4 is 16. With the b's, I have to add the exponents. So I have 3/2. This one has an invisible exponent of 1. So I need common denominators, which would be 2. So I get 5/2. So I have b to the 5/2. There's nothing to combine with the c's, so I have c to the 2/3. Now, anything that's a fractional exponent, I need to rewrite. So now I have 16. B goes in the radical. The 2 of the denominator goes on the shelf. And the 5 is the exponent. On the next one, C goes into the radical. 3 goes on the shelf. 2 is the exponent. But before I can say I'm done, I need to check to see if they simplify more. So I know 16 is good. But this first one, the B's, is looking for groups of 2. Well, I do have groups of 2 and 5. So this is b squared, and then there's a b left over. Now, when the exponent is this, not the exponent, the number on the shelf is a 2, technically we don't write it. But if you do write it, I'm not going to count it wrong. If I look at the C's, I'm looking for groups of 3s. Well, I can't form a group of 3 and 2, so that one doesn't need to change. And so now I'm done. Number 11. Before I want to do that power to a power, I want to simplify anything that I can inside of that parentheses. So the x to the 8 has nothing to simplify with, so it's just x to the 8. The y's, this is division, so I'm going to subtract the exponents. This one has an invisible exponent of 1, so I have 1 minus 1/2, which we know is 1/2. So I have y to the 1/2. And this whole thing is raised to the 3/2. So now I'm going to distribute that exponent and multiply. So 8 times 3/2, I can simplify, and that gives me 12. If I didn't simplify, I'd have 20 over 2, which is still 12. Or excuse me, 24 over 2, which is still 12. All right, with the y's, that gives me 1/2 times 3/2. So that gives me 3/4 when I multiply. So I have y to the 3/4. So now when I simplify, I'm going to have x to the 12. Y goes on the radical, 4 on the shelf, 3 is my exponent. Now we can check. Do we have groups of 4 and 3? We do not, so we're good to go. Now, even though 11 and 12 look different, 11 and 12 have the same idea. You got to simplify inside first and then take the cube root. So 250 divided by 2 is 125. With the x's, there's 6 on top and none on the bottom, so I simplify and get 6 on the top. With the i's, there's not the i's, the y's, there's 2 on the top and 11 on the bottom. So when I simplify, I get 9 left over on the bottom. And now I'm going to take the cube root of all of that. Well, the cube root of 125 is 5. For the x's, we're looking for groups of 3. 6 divided by 3 is 2, so there's 2 groups. And with the y, there are 3 groups, and that's my final answer. By simplifying inside first, it's going to make your life way, way easier. If we look at number 13, again, combine it and simplify, then do the radical. Well, these are all multiplied. So now I have the cube root of 16 times 4 is 64. With the x's, when you multiply, you add the exponent. So 2 times 2 is 4, times 5 is 9. So I have x to the 9. Now simplifying this is no big deal. The cube root of 64 is 4. And then the cube root of x to the 9th is x to the 3rd because there's 3 groups of 3. And we're done. By simplifying it, you're going to find I'm going to intentionally give you ones that simplify very easily. Number 14, to simplify that fraction, we have to multiply by the conjugate of the bottom. And the conjugate of 3 plus the square root of 2 is 3 minus the square root of 2. On top, I need to distribute. So that gives me 36 minus 12 times radical 2 be 12 radical 2. On the bottom, because it's the conjugate, I can do the shortcut. 3 times 3 is 9. Positive times a negative is a negative. Square root 2 times square root 2 is 2. Even though we would like to, we cannot simplify these numbers yet. We have to subtract the bottom first. So this gives me 36 minus 12 square root 2 over 7. Now we're going to ignore that radical 2 for a second and see if anything goes into 36, 12, and 7. And nothing does, so we know we've got our final answer. Okay, number 15, we are multiplying. When you multiply, you can multiply the numbers outside and we get 30. And you can multiply the numbers in the radical and we get 20. But 20 simplifies, 2 and 10, 2 and 5, we got a pair of 2's. But that 30, it didn't change, it's still outside. But now we can bring out the 2 and there's a 5 left over. And we do that, 30 times 2 is 60, and we get 60 square root 5. Number 16, we're not multiplying. When you multiply, you can multiply anything you want. When you're adding and subtracting, you can only add and subtract if you have the same number under the radical. So that means since we don't have the same number under the radical, we're going to have to simplify. So 12 is going to be 3 and 4 and 2 and 2. So the negative 8, it's going to come out. The 2, it's going to come out. And then this 3 is left over. So I get negative 16 square root 3 plus, let's do this again. This is 3 and 9 and 3 and 3. So the 6 comes out. So can that group of 3, and there's a 3 left over. So we get 18 square root 3. So when we add it together, we get 2 square root 3. Almost done. On 17, we're squaring the radical. And when you square the radical, we can just square each term. So 7 squared is 49. And we don't add, we multiply. And the square root of 6 squared, the radical cancels and we get 6. And then, grab my calculator, we have 49 times 6, which gives us 294 for our answer. On our last problem, we have a binomial times a binomial. So you got to FOIL or distribute, whatever you want to call it. So 4 square root 5 times 4 square root 5. Well, 4 times 4 is 16. Square root of 5 times square root of 5 is 5. On the next one, 4 square root 5 times negative 8. Well, 4 times negative 8 would be negative 32 square root 5. In the middle, negative 7 times 4 is negative 28 square root 5. And at the end, a negative times a positive would be positive 56. Before we combine like terms, we want to recognize that 16 times 5 is really 80. Now we can combine like terms. 80 and 56 gives us 136. And then we add the terms in the middle, negative 32 and negative 28 would be negative 60 square root 5. Now on the quiz, you're also going to have, excuse me, not on the quiz, on the test, you're also going to have solving radical equations, graphing radicals, graphing cubes, and the review stuff that we've done on parabolas. But all of that is on your test review, and you can check your answers to the test review in Google Classroom.